Hey y'all, so we are about to start 7E probability. This is probability and counting. Okay, counting and probability. Let me share my screen. There we go. So you see my dot cam. Perfect. Hopefully you're seeing it. Yeah, awesome. So starting off with factorial that I believe you started in 1300. So just refresher. The factorial is when you have that in exclamation mark, right? Exclamation is what we use for the factorial notation itself. So it's just n times n minus one times n minus two times, all the way down to just two times one. I'll put these in its own little term. So a lot of times I don't even bother doing the times one because, well, what's one times anything? One. So if I have an example of like 5 factorial, that's just 5 times 4 times 3 times 2. So 5 times 4 is 20, times 2 is 40, times 3 is 120. And there you go, that's it. So if I have, let's see, like oops, 5 factorial divided by 3 factorial, well, then you do the expansion first, and then you do any reducing, right? You do the expansion first, and then you reduce. So that is just 20. Okay. So if you have any division factorial like that, you do the expansion first and then reduce. All right. So here we're getting into more of the counting aspect of it. So arrangements with repetition. So basically like a password where you can have, the number 5 however many times you want. So your book definition. If we make our selection from a group of n, group of, pardon me, of n of n choices, oh gosh, I can't write, a total of n times n times n times n r times, well, that is equal to n to the r. Okay, different arrangement are possible. Possible. Cool. So we've got, if we make our selections from a group of n choices, a total of n times n times n, blah, 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 r times equals n to the r, different arrangement possible. So arrangement is a really big key word here. Arrangement means like you put it in a specific order. Like a password is an arrangement. It's not like things are really nilly. You put them in a specific order. Like if your password is 1234, then you cannot expect 4321 to unlock, whatever it is you're trying to open. So here's an example. Here's a couple examples. Suppose a state has license plates that display 7 numbers. So it's 1, 2, 3, 4, 5, 6, 7 numbers. How many different 7-number license plates are possible? So we have R times. This is our R times, right? And then there are N choices. So numbers, there are 10 numbers, but it's 0 through 9 digits, right? 1 through 9 plus 0 is 10. So assuming that I'm allowed to replace uh, or repeat numbers, we have 10 times 10 times 10 times 10 times 10 times 10 times 10, or 10 to the 7th power. So that is a 1 with 7 zeros behind it. Oops, excuse me, 1 comma. So 10 million. There's 10 million options for license plates, but 10 million usually is not enough. Like if you think of a whole state, especially if like one city has a couple million already and by itself. We need letters and numbers. So assuming we still have the same seven, 1, 2, 3, 4, 5, 6, 7. License plates are a combination of both numbers and letters used in any order. Okay. So the fact that it doesn't say repeats are not allowable, we imply that to mean we can repeat. So there are 26 letters in our alphabet plus the 10 digits. Okay, that means that is 36 options. Oops, hang on. There we go. Options. So this is 36 times 36, 36, 7 times. Or 36 to the 7th power, right? And that, if you pop it into your calculator, oh boy, big number. 78,364,164,096. Okay, a ton of options. A load of options. Okay, so that's counting. If repetitions are allowed, repeat allowed. Repeat allowed. We're about to get into, well, what if repeats aren't allowed? Let me zoom out a little bit so we can see the full page. There we go. Let me close that up. Move that out of my way. With the paper. All right. So here again with passwords. How many 6-character passwords can be made if you can choose from uppercase, lowercase, numbers, and the 5 characters, the at sign, dollar, exclamation, asterisk, and the ampersand? Well, here we're using the multiplication principle because there are 6 letters. 6, 1, 2, 3, 4, 5, 6. Okay, so 6-character passwords. But how many options do we have? We can choose from uppercase letters. So uppercase letters, that's 26. Lowercase, that's 26. Numbers is 9. And these 5 characters, right? So that is 26 plus 26 plus 9 plus 5, which is a total of 67. Okay. So here we're allowed repeats because of the fact it doesn't tell us we're not allowed repeats. So that's 67 times 67 times 67 times 67, 67, 67. So many 67. Okay. Or 67 to the 6 because it's a 6-character password. That's cool. So if you pop that into your calculator, big number. Let's see, 458, 382, 169. Hundreds, thousands, millions. So 90, let's say 90.5 billion options. Boy, oh boy, it's a lot. Okay, so now we are doing a schedule. 6 different classes. Okay. Here, the difference is that we cannot repeat classes, right? Because you probably wouldn't want to do, well, you are doing math twice, but sorry, you probably wouldn't want to do math twice, right? So here we have the implication of cannot repeat because you're doing a schedule. The middle school principal needs to schedule 6 different classes: algebra, English, history, Spanish, science, and gym in 6 different periods. So 1, 2, 3, 4, 5, 6, right? You've got first period, second period, third period, blah, blah, blah. How many different class schedules are possible? Well, first period, maybe that is gym. I don't know, right? But we still have 6 options. Let's say it's algebra. So we get rid of algebra. Now we have 1, 2, 3, 4, 5 options for second period. Maybe that is English. Now there's 4 options. 1, 2, 3, 4. All right, now maybe this is gym. Whoops, excuse me. I wrote a 6, 3. All right, so here there are 6, 5, 4, 3. 2, and then 1 option. Because you had 6 to begin with. Then you took algebra, 1, 2, 3, 4, 5. Then you did history, 1, 2, 3, 4. So then there's science, Spanish, science, and gym. Maybe now it's science and gym, and you have gym last. So here, because you cannot have repeats, you're going down by 1, or this is thought of as 6 factorial. Right? Isn't that cool? So 6 factorial, which is 720, right? Because that's what 120 times 6 is. So just for like well, 720 different class schedules. So one student can have 720 different versions of their class schedule. Okay. I want y'all to try 4 on your own. So just press pause. And then when you're ready, come back and press play. Okay. So now we've got 10 swimmers and we need a 4-person relay. 1, 2, 3, 4. So with the relay, only one person can go at a time. So we've got 10 people to choose from at first. Then we have 9, then 8, and then 7. Okay. So this can be thought of if I need 10, 9, 8, 10 times 9 times 8 times 7, which we can just pop into the calculator and we can get that this is 5,040. But mathematically, right, if we're using the factorial, we can think of this as 10 factorial divided by 6 factorial, right? Because back from here, if we expanded it out, see how the 3 factorial got rid of everything 3 and less? Here, this gets rid of everything of 6 and less. So you have 10, 9, 8, 7, 6. Oop, oop, oop. Sorry, I'm having to squeeze it in here. Times 6 factorial. So notice how those disappear. Okay. So you can do it either way, right? So you have your 4 positions, start with the number of options and then reduce by 1, or think of it in terms of its factorial. But again, here we need to say that, note that this cannot repeat. Okay, things cannot repeat. And the order matters. And orders matters, right? Because if you're a coach, it totally matters to you whether who starts the race and who ends the race, right? Every position has every swimmer has to have a what am I trying to say? Y'all know what I'm trying to say. Like they have their own aspect to them. Maybe someone's really good off of the starting block. Someone's really good under pressure at the end. And then your middle two are just, super fast. I don't know. Not a coach. But anyways, the order matters. Your coach puts a lot of thought into who goes first, second, third, and fourth. So we're going to generalize this and put it into a definition. Permutations. So they occur whenever one, all selections, selections come from a single group of items. Like here, these were swimmers on the swim team, right? They came from the same group of people, the whole varsity team, if you would, maybe. No item or person, may be selected, may be selected more than once. So no repeat. And the order of the arrangement matter, right? It's an arrangement. You are arranging things in an item. You are taking time to put them in a very specific order. Okay. So the formula for this, which I highly recommend you put on your note card for this next test, is NPR. Okay. So this is the permutation of n items chosen at r at a time. It is n factorial over n minus r factorial. It's an n, not a weird h, which is the n times n minus 1 times n minus 2, so on and so forth, all the way to n minus r plus 1, divided by your total of r factorial factors. Okay. So basically this right here, because I have 10 factorial over 10 minus 4 factorial, which is 6, right? Isn't that cool? So we're just dividing it out. We're dividing them out because if this is the multiplication principle, if I need to get rid of these last 6, then we are dividing them out. Perfect. So there is a button on this on your calculator. Let's see, I only have this one on hand. Maybe I can find the other one. But if you go into, where is it? Math, and then probability. See, it has your NPR, your permutation, and then a hot second, we are going to talk about combination, NCR. Let's see if I can grab this calculator real fast. Grab. Oi, sorry, y'all. I'm fishing in my bag. Fish. Here. Here we go. I got it. Makes for good video, huh? Okay, so here's my cheaper one. Put it in the light a little more. There we go. All right, so it too has it. Where is it? Probability. So just this PBR button, and then here's your NPR, here's your NCR, and then here's your factorial button. Okay, so you don't have to get this high dollar 100 plus. I think this is like 12, 15. I think it's like 12 at HEB, Target, Amazon, whatever. Okay. So like the swimming one, if I do this, this would be 10 probability NPR, 6. Oh no, 4. Sorry. We're doing 4 swimmers. Ta-da! Okay. So it would be the same thing here. So 10 P, oh gosh, I did it again. 4. See? So both you can totally use your calculator, that's fine. It shows me that you know that you're choosing permutation over combination, you know what's going on. You're just letting the calculator do the math for you, which is fine. Okay, you're showing me that you have the concept, which is the big deal. Yeah, so we're good there. So here again is the formula. It's read as the number of permutations of n items taken are at a time. But sometimes I just say NPR. Not a big deal. Okay. So let's see, we already did that. So moving on to example 5. Oh, wait, maybe not. We're going to pause the video because my husband is calling. We'll be right back after this short break.